Welcome to the final presentation for Management 530 Business Analytics for Managers. I am Brad Simon. This presentation required data to be cleaned and analyzed from a file source provided by the course. The data used for this presentation is from the FAA website, text file A2015_19. This file collection is of data from accident and incident reports from 2015 to 2018. This file had hundreds of columns and thousands of rows. The data was examined and 5 column data elements were selected. The selected data elements columns include the control number. This is the report identification number. The type of element. This is only an accident or incident. The number of hours the pilot has flown this particular model of aircraft from this report. The total flight hours of the pilot and the pilot's date of birth. Now in these columns, hours flown for the model aircraft and the total flight hours, there was a lot of missing data or empty cells. The data was cleaned up by putting the average hours for each column in the empty cells. The average hours flown for the model of aircraft is 672, and the average for the total flight hours is 3,927. The pilot's date of birth was treated a little bit different. This data needed to be cleaned as well. The dates were transposed so that the new column could be created for the pilot's age at the time of the report. Data using the average age of 55 was used for some charts and graphs, while there are some charts and graphs that do not use an average to give a closer and possibly more accurate look at the difference in the reports. What can this data provide? While cleaning the data, I tried to keep this in mind while narrowing down the number of columns. Many items can be compared to each other. Many questions can be asked of the data. Is there a correlation between age and type of event? Is there a difference in how many accidents and incidences there were at certain ages? Is there a link between the hours flown, the age of the pilot, and the type of event? Is there a time in a pilot's flying career that they are most susceptible to an accident or incident? This is just a few of the questions that come to mind when looking at the raw data. Let's take a look at some of the graphs and charts from this data. The total number of events broken down into the different age brackets. The average age was used for missing data for this chart. Again, the average age was 55, and there is a definite spike at 48 to 57 years old age group. I feel this graph shows where there is a rise in events even with a large number of age entries due to default. I find this chart interesting. In most cases, you would assume that the younger and more inexperienced pilots would have more reports of accidents and incidences. This makes you ask, why is there a rise in events with older pilots? Again, using an average age, this graph shows the average age is for each report of event type. Since the average was 55 for missing data, there still shows some difference in the report types. Accidents seem to be slightly higher than 55 and incidents are slightly lower than 55. In later graphs, you'll see the difference in the number of events reported with no average age in the data. This graph shows that there is a difference in age between accidents and incidences. A similar scenario is used in this graph. The data that is being compared is the average hours the pilot has flown that model of aircraft and compared with accidents and incidences. This data shows a clear difference. There are more incidents than accidents when compared to the average hours flown for the model of aircraft. This graph compares the average total hours flown to each report type. The data results are very similar to the last graph where there are more incidents than accidents when compared to the average total hours flown. These two graphs show that there are really not a great deal of difference between the total hours a pilot has flown to the average number of hours the pilot had flown in the model aircraft that they were flying. When putting together all these graphs, I found this one probably the most interesting and puzzling at the same time. This takes the total flight hours and breaks it down into different report types in each age bracket. The number has a steady increase of flight hours through each age bracket. There's a natural progression. With more age, more time has been put into flight hours. The puzzling numbers is the last two age groups. There were only a handful of pilots in those age groups, but yet the total flight hours for each report type was still very high. These next few graphs, the average on the age was not used in the data. The graphs show the amount of missing data and represents the other accidents and incident reports accurately when age is used. This graph compares the pilot's total hours flown broken down into different age brackets. Like one of the previous graphs shown that was using average age, this shows a clear rise and fall in age brackets and total hours flown that reported an accident or incident. There is a substantial jump in the age bracket of 48 to 57 and another jump to the next age bracket of 58 to 67, and it remains pretty close to the same through the age of 77, and then the number reported of events plummet. Now note the large number of data not used in the quote-unquote blank age bracket to the left. Now, if there were good data, would it make a difference in how this graph reads? Why is there such a big difference of reported accidents and incidents in these experienced age groups? This graph is very similar to the last. The difference is it separates the accidents and incidences. Again, note the blank age bracket and the total number of hours for the model aircraft in each report. The interesting points to this graph is that the lowest age groups and the oldest age groups have more incidents and less accidents. But in the ages between 58 to 77, the number of accidents surpass the incidents quite a bit when comparing the total flight hours in the model of aircraft per report type. All the graphs are showing similar results of more accidents and incidents of pilots who are older and have more flying hours or flying experience. This final graph is just like the last, except this one is for the total flight hours. The number of incidents increased when compared to the total flight hours. However, the number of report events remain about the same in the age bracket between 48 and 77. The data selected for this project has shown interesting results. Using an average from the missing data for the pilot's age does not show a significant difference in the results. Using the average just showed an increase in the hours flown. Without an average, the graphs have shown a similar result in the age bracket in both accidents and incidences. As for the other graphs, they show a trend where more accidents and incidents are happening to pilots between 48 and 77 years of age, with a significant amount of flying time with that model of aircraft and for total flight hours. This data results in the question, are pilots becoming complacent for safety as they gain experience and log flight time? For future analytics on this FAA data could show more correlation of a pilot's age in relation to accidents and incidences. This presentation was just for one data file. There would be better data if all of the data files were clean and examined in the same manner. With all this data stored, there could be other analytics ran to maybe find other relationships with accidents and incidences that could bring insight on issues and help flight safety in the future. I hope you have found this video insightful, using a time frame of FAA accident and incident data to show the relationships between accidents and incidences with flight hours and the pilot's age. This concludes my presentation. Thank you.